Hey, what's up everybody? If this is your first time here, my name is Kevin Toppenberg. I've been restoring a 1935 South Bend lathe with a 15-inch swing. We got a good show for you today. We're going to work on cutting off an old worn out lead screw for the cross slide and get that replaced with something that's new. So if you'd like to see how that turns out, come along. I'm going to work on the cross slide screw. This is the brass nut. And I've been a little concerned about whether this is going to be, the wear is going to be a problem here. If you look right in the middle, that's how much play I have. And here it is at the end. It's a little bit. So that play is going to be from wear in the nut, whereas in the middle it was both the wear in the nut and the wear on the threads. I'm going to install it, and then I'm going to come back and look and see how much backlash I have and see whether it's worth taking it back apart and replacing this lead screw and this nut. Hey guys, I've talked before about this has wear in it, and it leads to quite a bit of slop, really like 100 thousandths by the time we have the loose nut and the wear on the threads. This is an 11/16 inch thread, 8 threads per inch. I'm going to replace it with the one that's a little bit bigger, which is 3/4 inch. As far as the nut, I have two options. The repair of the cross slide thread and the nut really go hand in hand, but for the sake of time, I'm going to separate them into two separate videos. So I'm going to skip over this part right now where I'm explaining about my options for the nut, and we'll get back to that in a future video. But my job for right now is this part from here to right about there is 12 inches. And this bar that I bought is 24 inches. So I'm going to, first of all, taper the ends just to see how it cuts, then part it off in the middle. Then I'll need to take a part of it down to a 1/2 inch. That's the 1/2 inch diameter. I'll then need to cut this off and put a 1/2 inch hole there. And so actually I'll probably make this a little bit over a 1/2 inch. So I'd like to be like a 1/1000 interference fit. And then afterwards I'll drill and put a pin through. So that's my goal. I'm actually pretty terrified about this. Lots of ways to screw it up. Hope I can do good. That cuts pretty well. Something is moving, and it's not the bit into the workpiece. It must be that sliding. That's better. I know you're not supposed to have this end supported when you're parting off. I'm gonna get it most of the way down and then take it out of here. If you get down real close, then it could, pinch it off. So I'll take that off later. And I have measured off here exactly 12 inches. Slip it in the collet. Hooray! My bit is broken here. I don't know, that must have happened right at the last second. I don't know how it happened, but it's broken. Okay, I've swapped this end for end. This is now going to be the end we're going to take down to just over 500 thousandths, so probably 501 or 502. And we're going to take off 3/4 of an inch in length. you can't see it, but this lathe has a DRO, and man, that's the first time I've really been able to work with one. It is so much nicer. All right, that's 694. So we'll put that in, 0.694, enter. All right, so we can just go from there, and I'll check it as we go along. So let's... Let's see how good this DRO. It's reading out 622 thousandths. Let's see what we get with this. $622.5. That's pretty sweet. All right. Go to 580. That's 510. All right, this is 501.8. I'm not sure it even cut that thing. I think wasn't taking deep enough cut. Still 503. I think I'm going to hit that a little bit with a file. $502. Still 502. $501. Levi's 501 jeans. Right on the money. All right. Okay, next I'm going to part off the old one right here, and then we'll drill out inside here. Man, using a good lathe, it is so much easier with parting. When I do this on my little Craftsman lathes, and there's all the laxity, and the part like will grab and like try to raise up, and then all the flex comes in, and it's like it's trying to roll up on top of the cutter. None of that here. It just cuts off. It's like easy. All right, I'm set up here in the 3-jaw chuck, and this has got a ton of stick out, so I'm gonna have to go real easy. I just noticed that this moves independent of that, so that's not gonna work. I'm gonna have to figure out something else. All right, so I got this set up here. This shaft has 2 parts. It has an inner where there's the gear, and then where the lead screw attaches. It then goes through a rotating sleeve, which is what connects to the carriage, and then the shaft sticks out again. So I've got the shaft into a collet. Then I needed to have some support, so I've got this steady rest, and for some reason my arm's not coming out here, so I had to use a block, but this is not going to be rotating, so I don't need to worry about that. So I've just got it nice and straight. That's good. And when I put an indicator on there, it's about a half thou run out. Okay, so I did some drill bits, got it up to about 400 thousandths. I'm gonna try getting the bore diameter to 499 thousandths. That'll be 1 thou under. My shaft is 1 thou over. That'll give a 2 thou fit. And then I'm gonna try to heat it up and get them together that way. So what I'm doing right now is using a boring bar to go up in there, and it's a pretty tight fit. So I'm having to actually cut a little bit above the center line because otherwise this bar won't fit up in there. So it's kind of squawking a little bit, but it is cutting. I got chips to prove I'm cutting. All right, my DRO reads 485. I'm just going to confirm that with a snap gauge. Reading 10 thousandths under my DRO, so I'm not sure if I trust this gauge or not. Let me try again. This says 470, 479, and that says 485. Do it again. 478.5. I'm going to say 9, round up. So that way the DRO will get to my destination sooner. So it might be undersized rather than over. Okay. All right, now that my hole's a little bit bigger, I was able to go back and drop my boring bar back down to center. That says 488. All right, that's 492. Well, for my final internal measure, it's a little bit tricky because as I'm closing down the micrometer, these things are spring-loaded, and depending on how much I crank, it just squishes it. But I think with just being ever so careful, I think I'm 499. So right on. So that's going to be it for today. My battery's going low, and I need to get everything all cleaned up. And we'll work on this some more another day. Now guys, future Kevin here again. I apologize I did not catch on camera when we put the two parts back together. Involved a torch and a lot of people standing around, and it just didn't seem the right time to pull out my camera. But what we did is to had our expert from the welding area bring a acetylene torch, and he was standing on that right side behind that wall from the lathe, and he had the torch so it was facing upward, and you know, we didn't want to get the ways hot, and just kind of gently heat it, just got it to a red hot heat, and then we slipped the screw in and put it in so that the live center was in the indent, pushed it in, and then just let it rotate as it was cooling. Only took a few minutes. It worked real well.
Three days later.
What's up guys? I've replaced my lead screw here. It was initially 11/16 and I've replaced it with a 3/4. It's 8 threads per inch. This part here is 12 inches. Took that off, machined it. I think it's 1/2 inch. I made it 1/1000 over on this part. Bored out a hole in here. Made it 1/1000 undersize. Then we heated this up and put that in there. Then drilled a hole, tapered it, and put a taper pin in there. Now the taper pin is sticking out, and usually taper pins are cut off flush, but I have had such trouble with taper pins that I'm trying to make it nice for the next guy so he'll be able to tell more easily which is which and that it's a taper pin. This is gonna be hidden inside. No one's gonna see it. So I'm gonna leave it like that for now unless my OCD kicks in and I have to come back and cut it off, but for right now. All right, let me show you about putting it in. Now this goes in like this. There's a gear right underneath here that these splines have to mesh with, so you have to kind of wiggle a little bit to get that on there if it catches. Like there it's catching. There, just wiggle this a little bit to get it to mesh with those gears, and then it goes on. And here's that pin inside there. It's got good clearance. Not gonna hit anything. So now I need to get my nut going there, and I'm in the process of redoing the nut for the cross slide here. Okay, setting up my indicator here. I've got 31 thousandths flux, but I also noticed that I'm getting some movement right here. So part of this laxity is coming from inside this bearing. I think I'm going to take this back out and look at it and see if I can figure out where that's coming from. So in this cross lead screw, there's this stationary part and then there's a part that rotates free. And right at the interface of those two, there's something that looks dark, and then there's a brass ring, and then either metal or some other material, and then the solid part. And I don't know if that'll show there, but this part is sliding back and forth on that. And that's where that 30 thousandths of play is coming from. Now, there is a set screw that is tapped right here. At the base, I can see the rotary shaft. There's no indentations, there's nothing in there. So I really don't know what that set screw does, other than maybe open up an area for you to put oil down in there. And that would make sense. But then there's one on this other side that could also be used for oil, and it is not tapped. So I don't know what's up with that. So I'm going to have to go online and see if I can find out how this piece is held in there. This cap here, actually it looks like maybe it slid out. It may be that cap is what holds that down on there. I'm going to try to see if I can push that way, and it may be that this cross piece here, I don't know if I'm pointing it out right, maybe this cross piece needs to be better fastened. Okay, I've got this held by the flats so I can get some good tension on there. My goal is to drive this inward. I'm going to use a deep socket, but that won't quite go down far enough. So I'm going to use some washers as spacers. Yeah, I don't know if that's going to work, because what needs to happen is the base needs to be lifted up and then pushed down. So I really need to be squeezing between that and the end here. I don't know how that's going to work. What if I do like this? Well, that has taken some of that slop out, but what's going to keep it there? Not real thrilled about banging on my lead screw. That's wood down there. Yeah, I think right in here, there's a little pin. And when I first got it, it was slopping quite a bit. And so I made a pin that went in there. But now I'm thinking that maybe, because it looks to me like that has changed in position, like somehow that is sliding out. Like that pin is not enough to keep it. And I'm thinking that maybe I just need to drill all the way through on that. I mean, ideally, if there was a nut that could tighten that up, that would be even better. Let me think about it. Okay, I've set up this avalanche waiting to happen. This is a homemade press, and I'm pressing between here. I've got that on washers pushing upward, and a deep socket and washers pushing downward. Looking to take out that gap in there. Now I've got it so that it's kind of tight to turn. Now let's take off the pressure and see if that stays. This is back moving easy again. Let me take it out and see if there's any less slop. With all of that, I've taken it from where I think it was initially 30 thousandths, and now just about 10 thousandths. I wish it was more like 5, because I think that would be enough for it to move, but I don't think I can get it any better than that. All right, I'm going to put the cross slide back on and then see what my end play is. Okay, here's the final result. I've got it set on 0, and I can flex it like 7 thousandths, 6 or 7 thousandths. Then I get that movement from the lead screw, the inside part. So I think I'm getting about 6 or 7 from the nut.
Lot of boring math later.
So 18, getting like 18 from the clunk, and then like 6 from just before I get to that point. So that's as good as I can do it. We'll just have to hope that's good enough. Thanks for watching, guys. I have to remind myself that the lathe is like 80 years old. It's not going to be perfect. I have actually done some cutting on it since then, and the cross slide seems to be working real well. I didn't get any vibration or flexing or any of that stuff that I have to deal with my small Craftsman lathe. So I'm real happy with that, how it's turned out. I think the lead screw worked real well, and I may still be able to come back and tweak that collar a little bit more in the future. Really, there's nothing that's going to prevent me from working on it again later if I'd like. But for right now, I'm happy with that. If you like this, can you please give it a thumbs up and love comments, and stay tuned for the next one, which is where we're going to be talking about that nut and making a holder and adapter and tapping and all kinds of cool stuff. All right, thanks.
Sowing seeds and secret themes, imagining the change I wish to see, to be, planted deep down where it stands on fertile ground, embryo.
Peace out.